Okay, we're looking at another example of a box and whisker plot where we compare two distributions. We say distribution A and distribution B. Okay, in distribution A, we're going to determine the 5-number summary and draw the box and whisker plot for the following data. In distribution B, we're going to produce the same on the same graph, we're going to produce a box and whisker plot for distribution B. And these are going to go into two different calculator lists, but they're going to appear simultaneously on the same graph. So let me demonstrate. Okay, so take a minute and put L1, or rather you can use any list you want. I'm going to use L1 and L2. Okay, so you're going to put your data set, one data set in L1, so stat, edit. I'm going to erase the data that's in L1 now. Okay, 67, 67, 90. 86, 55, 57, 60, 87, 72, 75, 70, 67, 62, 66, 63, 65, 83, 78, 64. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, so that corresponds with the 19 values we have. In L2, I'm going to put 73, 73, 86. 79, 82. Okay, that I missed the 79. Let's try that again. 79, 82, 87, 81, 85, 88, 80, 86, 79, 95, 94, 94, 76, 78, 83, 82. Okay, I'm missing a data value. Let's see where I'm missing it. 82, 83, 78, 76, 94. Okay, I'm missing a 94. I must have... Okay, on your calculator, if ever you miss a data value and you want to insert it, there's an INS in blue above the delete key. If you do second INS, it inserts a blank line, and I could put in the 94 that I was missing. Okay, so once the two data sets are in the calculator, we are going to determine the 5-number summary and construct box and whisker plots for both of them. Okay, so let me show you how to do this on the same display. Okay, using second stat plot, instead of having just one plot turned on, we're going to turn on two plots. So the first one, let's hit enter. Make sure everything is correct. It's on. It's set to the box and whisker plot. It's using L1. That's perfect because that's where distribution A is. Frequency is set at 1. To go to plot 2, we can use our arrow up key and slide over to this menu option for plot 2. So using up and going over to the right and then hitting enter. Okay, I want to turn this one on as well, so I'm going to hit enter. Using the down arrow under type, I'm going to arrow to the right all the way to the box and whisker plot. I'll hit enter again. And under X list, I'm going to specify L2. Okay, so I just want to demonstrate again. Second stat plot. 2 of them should be on, and the third one is off. Okay, so make sure they're both on. You're going to go to the specific plot, 1 or 2, hit enter, and make sure 1 is highlighted in black there. Make sure its type is set at the box and whisker plot on the second row in the center. Make sure the list is specified appropriately. So I'm going to look at now plot 2. Make sure everything's set correctly. Okay, it's on. It's set to the box and whisker plot. Okay, the list didn't, I have to check that list. That did not work. Okay, second, L2, enter. Okay, so now the list is set. Okay, so plot 1 is set, plot 2 is set, press zoom. Again, this error seems to happen again. If you're getting the same error at home, just quit and then press zoom. Go down to number 9 again. Okay. I have a feeling I have an error on my... This is not familiar looking, so let me just go back and check my list. I have a small data value of 6. I don't believe that's correct. Okay, I must have put in something incorrectly. It should not be 6. Let me go back to my list. Okay. I see the problem. Shouldn't be a 6. Let's see. After a 62, there should be a 66 and then a 63. Okay, it happens. There we go. Okay, we're going to press zoom 9 again. Okay, that looks a little bit more familiar to me. Okay, so you have 2 box and whisker plots on the same graph. If you press the trace key, it begins flashing on the median of the top graph, which is distribution A. And you could use your arrow right and arrow left to get the 5-number summary. So for distribution A, the min is 55, Q1 is 63, the median is 67, the Q3, I said that wrong, I'm sorry. Q1 is 63, the median is 67, Q3 is 78, the max is 90. Now to get down to the distribution B, use your down arrow and you could scroll through these as well. It's already highlighting on the max, so I'm going to go through this from right to left. The max is 95, Q3 is 87, 82 is the median, Q1 is 79, and the minimum is 73. So comparing these two distributions, which of the two have the greater variability? Well, that answer should be based on the length of the box. The length of distribution A, the length of the box in distribution A is greater than the length of the box in distribution B, and therefore I would say that distribution A has the greater variability. In distribution B, it appears that actually in both the distributions A and B, it appears that the right whisker is longer in both cases than the left. Maybe only slightly longer, but still maybe a little bit longer, so we could say that the distribution is skewed to the right. And generally we can say that distribution A has got a greater range. I mean, look at the smallest data value and the largest data value in distribution A. The range is far greater than the range of the distribution of distribution B, where the smallest is 73 and the largest here is 95. Okay, so let's look at some of the questions that we can ask on this problem. Okay, so reproducing both of these box and whisker plots on paper, you can create a horizontal line that is marked at every 5, starting at 50. That would capture all of the data values. So distribution A, Q1 is 63, Q3 is 78, the median is 67, the min is 55, and the max is 90. Distribution B, Q1 is 79, Q3 is 87, the median is 82, the min is 73, and the max is 95. Okay, so I'm trying my best to keep with the horizontal axis. It may not be perfect here, but you get the general idea. It would be best if you can create box and whisker plots that are created with a ruler or the edge of a book or something that keeps it nice and neat. Okay, so let's suppose that those two distributions had relevance. Okay, let's suppose that the two distributions above represent test scores in a 4th grade math class in which the students were tested on elementary fraction concepts. In distribution A, a traditional teaching approach was used to teach students about fractions. In distribution B, a new method involving fraction games was used to teach students about fractions. Okay, so these two distributions represent test scores. Test scores. So 55, not a great test score. 90 is pretty great. Okay, test scores, 73 versus 95. So distribution A using a traditional teaching method, distribution B using fraction games. Okay, you should immediately see a difference in the two distributions, and you could make a conclusion about what the better approach to teaching was here. What is the 75, the 75th percentile for each distribution? So you locate Q3 for distribution A and you locate Q3 for distribution B. And those numbers can be found on the box and whisker plot. We're going to explain the meaning of the 75th percentile in each distribution. Okay, so an interpretation of what the 75th percentile means. And what do the differing values for the 75th percentile reveal to us about the effectiveness of the fraction games teaching method? So let's look at the 75th percentile. See if we could come up with an answer here. The 75th percentile, or Q3, for distribution A is a score of 78. The 75th percentile for distribution B is a score of 87. The meaning of the 78 in distribution A indicates that 75% of students had test scores at or below a 78 in distribution A, using the traditional fractions teaching method. In distribution B, 75% of the students had test scores at or below 87, using the fraction games teaching method. And what do the differing data values, 78 versus 87, for the 75th percentile reveal to you about the effectiveness of fraction games? Okay, so this is a question involving interpretation that you should maybe take a minute, pause the video, and write down what your best interpretation of what kind of conclusion you could make regarding fraction games. Okay, so here are the answers. 78 for A and 87 for B. And the explanation of the meaning of those 75th percentile is that in distribution A, 75% of students had test scores at or below 78, while in distribution B, 75% of the students had test scores at or below 87. And here's an interpretation of fraction games. The differing values for the 75th percentile in each data set reveal that students taught using the fraction games method generally have test scores higher than students taught using the traditional method. Okay, so if you were in a position of authority in a classroom, a teacher or an administrator, perhaps you would initiate change in the curriculum based on these kinds of student results. And that is the end of the lecture on box and whisker plot. This also concludes the end of Chapter 3. If you have any questions, you can leave your questions in the discussion forum or post them to the discussion forum for the whole class to see, or send me emails directly